All right, this is the September Limpopo Trial Exam Paper 2021. This is the question on Newton's laws. It says a box of mass 65 kilos slides down an incline as shown in the diagram below. The incline makes an angle of 20 degrees with the horizontal, and the frictional force acting on the box is constant. It says define the term frictional force. This is the force that opposes the motion of an object and acts parallel to the surface. You must have both halves of the definition. Your opposing motion of an object. If it says kinetic frictional force, it's the motion of a moving object. But if it just says frictional force, it's the motion of an object. Now it says draw a labeled free body diagram for the box as it slides down the incline. There are 3 marks we will need, 3 arrows. So the first thing that we have is the weight of the box acting downwards. Okay, the box is on the slope, okay, because it's sliding down the incline. So if there's the slope, we have a surface and an object. There will be the normal force acting at right angles to the slope. And then finally, if the box is going down the slope and we have friction, friction will be acting up the slope, and it's kinetic, so we can give it the label of little fk. The arrows must be drawn with a ruler, the arrows must touch the dot, and the arrows must be labeled for the 3 marks. Then it says, use the data in the graph to show that the magnitude of the acceleration of the box is 1,75 meters per second squared. And so it says to you here is the velocity time graph for the box as it moves down the incline as shown below. So what do we know here? There's 2 choices here. We can either say the gradient is delta V over delta T, which it is. Remember, the gradient is the change in Y over the change in X, which in this case is velocity over time. And as you know, even from the multiple choice in this question, acceleration is the change in velocity over the change in time. Or you could say, look over here is VI, look here over here is VF, and look at this lovely delta T over here and use an equation of motion. But me, because of projectile motion, I would rather use the gradient equals delta V over delta T, and then I'm going to take this point off the graph and this point off the graph. So what are my Y coordinates? Change in Y over change in X. It is going to be 6, 0 minus 2, 5 over the change in time, 2, 0 minus 0, because we went back to the origin. And if you put this in your calculator, you get 3.5 over 2, which is 1,75 meters per second per second. If you use the equation of motion, yes, Vf equals Vi plus A delta T, and you substitute in here 6 equals 2 plus A times 2, you end up with, sorry, not 2 over here, this is 2.5. You end up with exactly the same answer. You will end up with A equals 1,75 meters per second. So you will have proved that this is the magnitude of the acceleration of the box. Now, even if you couldn't prove it, remember that it says if you are asked to show something, you are allowed to use this value in your next calculation, whether you can prove it or not. So anytime they get asked you to show something, just carry on with your calculations, even if you can't prove something, okay? Then it says, state in words Newton's second law of motion. When a non-zero resultant net force acts on an object, the object accelerates in the direction of the net force at an acceleration which is directly proportional to the net force and inversely proportional to the mass of the object. 2 marks for the 2 halves of this. So now it says to you, and I just wrote over it, but it says calculate the net or resultant force acting on the box. So we've got Newton's second law. Newton's second law as a formula is F net equals ma. I know that the m is given in the question is 65 kilos. I've just proved that the acceleration is 1,75. So the net force is equal to the mass times the acceleration. So it will be 113,75 newtons if you plug it into your calculator. And it asked you what is the net force acting on the box. So you should by rights say down the slope. Okay, 113,75 newtons down the slope. And then it says to you, what is the magnitude of the kinetic frictional force acting on the box? So seeing as it says frictional force, we should accept any answer, shouldn't we? They should be more careful and make sure this says frictional force. But because we are clever, we know they were looking for friction and not a friction. So we're going to use the same F net equals MA. Okay, but now we are going to be informed by our force diagram over here. So we can only add vectors in a straight line. We are looking for the force that is going down the slope that is in line with the coefficient of kinetic friction, which is Fg parallel. Fg parallel is what is dragging the box down the slope, while Fk tries to keep it at the top of the slope. So we know from resolving forces that Fg parallel is equal to Fg sine theta, which is going to be mg sine theta. So if we take this back and substitute here, which forces have we got on the slope? If we say down the slope is positive, okay, which makes sense. If down the slope is positive, I have Fg parallel going down the slope and Fk going up the slope, so its sign becomes negative. So I would have here, what is the mass of the box? 65. What is G? 9.8 times the sine of 20 minus Fk, which I'm trying to calculate, is going to be equal to this answer over here, or you can substitute in the 65 and the 1,75. So you substitute in here 113,75, and this 65 times 9.8 times the sine of 20 is something like 217,867. Okay, and then when we take the Fk over to the other side, we end up with 217,867 minus 113,75, and that is going to give me the force of kinetic friction, which comes to 104,12 newtons. So this was a relatively uncomplicated Newton's law question. So one hopes nobody's watching this video because you all understood what was going on and you got full marks in this nice and easy question.